This short lecture is just going to take you through a couple of the big concepts I want you to have with regards to blood tracing that's going to be important for lecture. Most of the blood tracing you look at and the blood vessels you look at is something you're covering in lab exclusively, but there are three areas that I want to be sure that you're familiar with that I refer to in the lecture exams. So we'll do a very brief overview of the blood vessels. We'll look at the cerebral arterial circle, sometimes called the circle of Willis, the azygous system, which is a venous system, and the hepatic portal system, which is also a venous system. So this is that picture of blood vessels that you have at the very beginning of this section of chapter 21. You're not asked to know all of these blood vessels in lab, but quite a few of them are there. I even have a couple pictures on the Wiley Plus assignment that you have that comes from some images that look similar to this, or pictures of models. So it's good to have a general idea of these blood vessels. Just a kind of another look in. If you'll recall, at the beginning of the course, we talked in chapter 16 about the celiac plexus and the celiac trunk. Well, now it's at this point. Here's the celiac trunk. That main artery, it's the first major branch coming off the abdominal aorta. Here's the diaphragm, so I referred to that. Remember, we said that celiac plexus, or the solar plexus, was right there. There's a major network of nerves that surround these blood vessels, and then this trunk has branches that go off towards the splenic artery, the hepatic artery, and the gastric artery, all branch off the celiac trunk. What I want to focus on a little bit more so, though, is the blood flow heading up towards the brain. So that's what we're taking a look at here. This actually shows the branches off the heart. I left this slide in here because we have just completed talking about cardiac function. But we're going to really just take a look at what's going on here with the branches. You've got the left and right, well, you've got the brachiocephalic with the right common carotid here and the left common carotid going up here. And there's your left subclavian heading out towards the left arm. But we're looking at these two vessels here moving up towards the brain. And so this is a picture, all these are from your book, taking a look at that flow of blood to the brain and what forms what we call the cerebral arterial circle. So for instance, here's the left common carotid that branches up here. There's an external carotid there, and that our picture or flow chart stops right here. That actually will take you to the facial vein or facial arteries and the vessels that are on the external portions of the face. But what we want to branch to is go inside the brain, and from inside the brain we will go left internal carotid, which will then branch to both the left anterior cerebral and the left middle cerebral artery. So that internal carotid branches to 2 points there, and it actually, we're showing that it heads up and flows to make a circle in the brain. The right common carotid will do the same thing. It will go to a right middle cerebral artery and a right anterior cerebral artery. Likewise, you have blood that comes from the vertebral arteries. So if yes, I have this picture here. So here's the right common carotid coming up, and you'll see that branch here. This was the brachiocephalic coming up here to the right subclavian, and coming right off there is the right vertebral artery. It passes through the vertebral foramen, and then will enter up through the foramen magnum into the skull. And so if I look here, here's that vertebral artery coming together here. They're both one on the right side, one on the left side. They come together, they form a basilar artery. So there's the basilar artery right there. Likewise, you see these two vessels that are cut. We're looking at the undersurface of the brain. So these two vessels that are cut are actually the internal carotid arteries. So they would be extending toward, it's a two-dimensional picture, but they're extending down, also coming up the neck, but not through the vertebral column. So these two vessels, then remember, they branch to form both an anterior cerebral, which is actually running right here, and see it's shaded here because of the brain tissue, but the middle cerebral is coming off there. So here's that middle cerebral there, and here's the anterior cerebral. Now this anterior cerebral is this vessel coming up, and all of this around down here, with the middle cerebral coming this way. So you've got a left and a right side on both cases. So again, here's the internal carotid. Here's the branch coming here that then becomes middle cerebral and anterior cerebral, that passes right through here and continues on up this way right here. So left and right side of the brain are actually, when you take a look at it here, they've got matching vessels. Both carotids matching on both sides. Here's the vertebrals. You've got both of them matching as well. So they come together here, they form the basilar artery, and then they have a branch of a posterior cerebral coming off this way, and then also on this side coming off that way. So you've got the, in our picture, when you're taking a look at this, remember you're looking at the underside of the brain. Here's the anterior and the posterior view underside of the brain. So this is actually the right side of the brain, and this is the left side of the brain. So it's a little tricky when you're looking at this. You've got to take it and turn it over in order for it to sit correctly on the brain. You've got to think about what you're looking at. You're on the underside of the brain. This is the front, this is the back. In order to set this correctly in the skull, the whole thing flips over, and therefore this is the left side, this is the right side. So, two vertebrals coming up here, a basilar. Basilar then branches to a posterior cerebral, which is technically the right side, and a posterior cerebral here on the left side. And then from there also branches to what are called posterior communicating arteries. These two communicating, you can see a little bit clearer over here, these two communicating arteries will join up here right where that internal carotid in the middle and the anterior cerebrals come off. So they join right there. They communicate or connect the blood flow from the vertebrals to the blood flow from the internal carotid. So you have two pathways in, and they connect here. So the blood that's coming up this way will connect to the blood that's coming in from the internals through these two communicating arteries. Then you have these anterior cerebrals that go forward here and here, and they're connected by a single vessel called the anterior communicating. This vessel right here connects the left side to the right side. So there's just a single anterior communicating. When you look in lab, a lot of times this little vessel's broken. But it's a little tiny stem, what kind of looks like a letter H if you think about it. That little stem there is the anterior communicating artery. So that connects the left and right sides. So that's the cerebral arterial circle flow. In your book you have tables that look just like this, and I strongly encourage you to not only look at the flow charts and the pictures of the vessels, but you should also read what's written in these descriptions, because it'll take you through which vessel connects with which, explain the roles of posterior communicating arteries, anterior communicating arteries, and so forth. Tells you what areas of the brain are supplied, and really will do a great job on helping you understand this blood flow. So I encourage you, I'm not going through this whole table now, but I really strongly encourage you to read through these tables. That will help a lot. Here's that celiac trunk I mentioned before with the branches coming off, common hepatic, left gastric, and the splenic. So I like to point that out because we're going to take a look in a couple moments on the hepatic portal system. And so the hepatic portal system is a venous system, but it's picking up the blood that was delivered to these things such as the stomach, the pancreas, the spleen, and the small and large intestines. This hepatic portal system, which we're jumping to here, these are the veins, and this is showing you, by the way, the venous return to the brain. I'm not going to spend as much time with this, but this has that same concept of looking at how blood flows back down to the brain. But I want to jump ahead here. I want to look at the hepatic portal system. So in the hepatic portal system, what we're actually looking at here is here's those organs again: spleen, stomach, pancreas, and intestines. We delivered oxygenated blood to these areas. Then we picked up wastes in the venous side. Now we take that venous blood that has picked up what we ate and what we drank, what medications we may have taken in, and so forth, and we need to clean that blood up before we send it back through regular circulation. And that's what the liver's for, to clean our blood. So we want to pass that blood from whatever we ate or drank, whatever medications, we want to pass it through into the liver before we send it back up. So the sequence of blood flow then for that And notice my blood flow is going this way. These are the veins. We picked up blood in the superior mesenteric vein, the inferior mesenteric vein, the gastric vein, splenic vein. So these are coming from the different organs. The inferior mesenteric vein will actually join up with the splenic vein, or sometimes it joins the right and left gastric, but primarily it's going to join into the splenic vein. Now that I see this, I kind of wish this bullet point was up one, just so I don't confuse you. Superior mesenteric vein, right and left gastric veins, and splenic vein coming from the spleen, and some of the stomach also is flowing in there. Not all of the blood from the stomach goes into the gastric veins. These three vessels join together to form the hepatic portal vein. So if I look back to our picture, here's the hepatic portal vein. And what you have coming in there, here's your splenic vein coming in there. Here's your superior mesenteric vein coming in here. And then you have your left and right gastric veins. They're smaller coming in here, and they all come together and join at the hepatic portal vein. From there you branch into a portal system, a second set of capillary beds in the liver, and then coming out of there will be hepatic veins, which will join with the inferior vena cava. So in my flow, these vessels here join to the hepatic portal vein. They then pass through the liver, and they come out the hepatic veins into the inferior vena cava, and then blood flows back to the right atrium. So if you're doing blood flow in lab, be sure that you go from hepatic portal vein to the liver itself, where there's a capillary bed, to the hepatic veins, and then back through. I just listed the major vessels here. And so this picture also gives you that flow. Here's the abdominal aorta. Hepatic artery goes directly to the liver, but you also have all the blood that came from stomach, pancreas, large intestine, small intestine, stomach, many different things flowing into the two vessels to form the hepatic portal vein. And again, the gastric veins are joining here as well to the liver, capillary bed there, and working your way back through. So that's the hepatic portal system. All right, let me back up here a second. I really kind of jumped through this flow out of the brain. The pictures in the book don't do a great job of showing this drainage from the brain, but the flow chart does a fairly decent job of doing that. So as you're doing your blood tracing for the brain, be sure you come take a look at this, and also understand that all that blood is going to be flowing down into the jugulars. And if you take a look, the external jugular is a much smaller vessel, but the internal jugular is what's actually draining the brain. The internal jugular joins to the, kind of in a straight line, really, to the right and left brachiocephalic veins on each side. You've got this going on each side that will then go into the superior vena cava. So all the blood that's drained from the head, neck, and face does go into the brachiocephalic veins, right and left side, and then into the superior vena cava. You'll notice on this picture here, you can see the brachiocephalic on the left side coming into the superior vena cava. Now, the other thing I want to point out is these vessels that I highlighted in red here. We have something referred to as the azygous system, and that includes the azygous veins, which are running up the thoracic cavity, the accessory hemiazygous and hemiazygous. These three are in the thoracic cavity. In addition, you have a right and a left ascending lumbar veins, and those veins flow up and join up with the azygous system. And these veins join not at the inferior vena cava, but at the superior vena cava. This is an important concept for you to understand. Not all the blood from the lower portions of the body join at the inferior vena cava. This blood vessel is already overloaded with volume of blood coming back. And so some of the blood will work its way up through these ascending lumbar veins into the azygous system and drain back into the superior vena cava, where the gravity will pull that blood back into the heart. So you don't get a lot of time to look at these. These aren't on models on the lab, but they are on your list. You must know azygous, hemiazygous, accessory hemiazygous, and these ascending lumbar veins as alternate ways in which venous blood is returned up to the superior vena cava.